Okay, so we'll start with question 1, which is there. Okay, and what is our question 1 saying? Okay, they're saying a 0.384 gram sample of a gas, okay, is collected in a flask of volume 250.0 cubic centimeters. Okay, then they're saying the pressure in the flask is just 25 degrees Celsius. Okay, and then the pressure in the flask at this temperature is 120 kilopascals. Okay, then the question here is this gas, okay, the gas that is collected there, is the gas that is collected there, is it oxygen or is it nitrogen? Okay, so in short here, they are asking us for the identity of the gas. Okay, they want us to find the identity of the gas. And how do you find the identity of an element or an atom? Okay, it means you have either to find its atomic number, okay, or you have to find its molar mass. Okay, so once you find that molar mass, then you go on your periodic table, you compare whatever element is close to that molar mass that you found, or whatever element is close to that atomic number that you found. Okay, because they said the atomic number gives us the identity of the atom. Okay, so how do you go about this question? Okay, so these questions are all about gases, meaning we are just going to be using the ideal gas formula. Okay, and what does that ideal gas formula state? Okay, so the ideal gas formula states that when you multiply your pressure with the volume, okay, what you're going to get is the number of moles multiplied by the gas constant here, which is represented by R, and then multiplied by the temperature. Okay, so this formula here that you are seeing, guys, it's very, very important. Okay, because you are going to use it on almost all of the questions that involve gases, that involve gases relating to moles. Okay, so what's the first thing there? The first thing there is to make sure that we find this N here, because there on the question, we've been given the pressure, we've been given the volume, we've been given this gas constant is always given. So we know the gas constant, and again, we've been given the temperature. Okay, so make sure that your temperature, let me use a different color here. So before you solve anything, make sure that your temperature is in the appropriate units, which are kelvins. Okay, and then your pressure, make sure that it is in pascals, and then your volume, make sure that it is in cubic meters, like that. Okay, so make sure you change all the units that are not in their standard form to this standard form, then you can apply them into that formula. Okay, so in that question, what are we being given as our values? Okay, we've been given the volume. This is our volume here. We given the temperature there, and we've been given the pressure there. Okay, so you can see that this volume here is in centimeter cubic. So it means we have to change it to what? To meter cubic. Okay, this temperature here is in degrees Celsius, meaning we have to change it to kelvins. And then that pressure there is in kilopascals, meaning we have to change it to what? Pascals. Okay, so that's how you analyze a question. Then you just substitute them into that. Okay, so let's do that. Okay, so we've been given what there? We've been given a volume of, okay, 250 centimeter cubic. Okay, and we said we have to convert this centimeter cubic to the meter cubic. So how do you do that? You just multiply. Okay, how do you do that? You just multiply this number by 10 to the power minus 6. Okay, so converting this to cubic meters, you just multiply the number that you have there by 10 to the power minus 6. Okay, if you multiply by this, it means you've changed to meters cubic. Okay, so this is our volume. And then let's look at our pressure. Our pressure there, what have we been given? Okay, our pressure, we were given a 120 kilopascals. Okay, the 120 kilopascals. So this is a kilopascal. Kilo simply means 1,000. Okay, so 120 multiplied by 1,000. Okay, you can get 120,000 like that. Okay, so those are our pascals. And then what else? Okay, we said the temperature. The temperature there is 25 degrees. Okay, we have to change this 25 degrees to kelvins. So how do you change that? You just add a 273. Okay, meaning what are you going to have there? You're going to have a 298, okay, kelvins as our temperature. Okay, so you can see that we have our volume, temperature, pressure. Okay, then what is our gas constant? Okay, so our R is just always 8 point. Okay, so if this value always given 315, okay, kilo joules per kilo the kilo minus 1. Okay, this is a J. Okay, and then you have moles minus 1. Okay, those are the units there. So we have all what is needed there to find this number of moles. Okay, so we make the moles the subject to the formula there. What are you going to have? Okay, you're going to have, let me change the color there. You're going to have N is equals to, okay, PV over RT. Okay, then you just simply substitute this value that you have found there into that formula. Okay, so what is our P? Okay, what is our P, which is our pressure? Our pressure is just 120,000 there, multiplied by, okay, what is our V? Our volume there is what? Our volume is this, okay, so 250 multiplied by 10 minus 6, okay, over, what is our gas constant? It's this number here, guys, okay, so 8.315 multiplied by, what is our temperature, okay? Our temperature, we said it was 289 there, okay? Then you multiply this to find the number of moles, okay? Okay, so when you do this on your calculator, you should be confirming these values, okay? But when I do my calculations here, okay, when I do my calculations here, it's giving me what? Okay, let me do it. Okay, so my calculator is giving me a 0.012 moles, okay? These are the moles that I'm getting, okay? Now, after getting the moles, okay, I'll go back to my question here. After getting the moles, I'm going to use the moles with that mass that I've been given there to find my molar mass, okay? Those moles that are found there, I'm going to use it with this mass, okay, to find my molar mass. Then that molar mass, I'll compare it to the molar mass is on the periodic table, okay? So let me find that. These are my moles, and what is my mass? Okay, my mass there is just 0.384 grams. Okay, so how do I find my molar mass? Okay, remember that moles is equals to mass over molar mass. Okay, meaning my molar mass will be equals to what, guys? Molar mass will be equals to the mass over the number of moles. Okay, so what is the mass there? We said the mass is 0.384. And then what is my moles? Okay, my moles was, what are my number of moles? Okay, 0.012, 0.012 like that. Okay, so when I divide this, what is it giving me? Okay, so I have a 0.384 divided by a 0.012. Okay, so when I divide this, I'm getting a 32 there as my molar mass, so grams per mole. Okay, so now since my molar mass is 32 grams per mole, I go back to my question, I check. Okay, so the question was that, is that gas oxygen or is that gas nitrogen? Okay, so you can see that the gas there will be oxygen, because oxygen is the one that has 32 grams per mole as its molar mass. Okay, this nitrogen has another number. Okay, so that's how you find question 1 there. I don't know if you have any questions on question 1. Do we have any questions? Okay, silence means no questions. I'll move to question 2. Okay, so question 2, they are saying you are given a lump of elemental metal and some hydrochloric acid and asked to identify the metal. Okay, so whenever you see identify the metal, I said we have to find one, the atomic number or the molar mass. Okay, so this is our aim in this question, to find the atomic number or the molar mass of this metal there. Then if we find all those numbers, it will be easier for us to identify this metal. Okay, let me continue. So you decide to dissolve a 0.103 grams of the metal in excess hydrochloric acid, okay? And you collect the hydrogen gas, okay, given off in a flask at 1 atmospheres as your pressure, okay? And your temperature there is just this, okay? And then here they're showing us the reaction. They're saying 2 of the metals are combining with 6 of the hydrochloric acids to form 2 of these and 3 of the hydrogen, okay? So they're saying the volume of hydrogen collected is this value here. What is the metal? Okay, so we go back to this. For you to know the identity of the metal, you have to find the what, guys? You have to find the molar mass, okay, or the atomic number. So let's find that, okay? So here it means we first have to find the moles of this hydrogen here, okay? Then after finding the moles of this hydrogen, we can do a mole ratio of this metal and this hydrogen to know the number of moles of this metal, okay? Once we get the number of moles of this metal, we are going to combine those number of moles with the mass of the metal, okay, to get the molar mass, okay? And once we get the molar mass, we find the identity of this metal. Okay, so how are we going to solve for the moles of hydrogen? Okay, how are we going to solve the moles for the hydrogen? Okay, so remember I said we use the ideal gas formula. Okay, so number of moles is equals to PV over, you have RT there down, and we know the values of all this. Okay, so what is our P, what is our V, what is our R? Okay, so remember to put them in the appropriate units. Okay, so our V, which is the volume, okay, is just 78.3 milliliters, okay? Then you change this, I said you change them to what? You change them to meters or cubic meters, okay? So how do you change millimeters? Millimeters, how do you change them to liters? Okay, you just divide by 1,000 here, okay? When you divide by 1,000 here, you're going to get to 0.0783 liters there, okay? Then what is our temperature? So our temperature, what were we given there? Okay, our temperature were given 22.8 degrees Celsius. Okay, we're just simply going to add a 273 there to take this temperature to kelvins. Okay, when we add there, we are simply going to get a 296 kelvins there. Okay, then what is our pressure? Okay, our pressure, they said 1 atmosphere. Okay, 100 atmosphere. Okay, and then the R, we know it's what? It's 80 point, what is the R, guys? Okay, so the R, okay, so the R, I have to emphasize, okay, so the R that you get, don't get confused. The R that you use, okay, is dependent on the units that you have for the volume and the temperature, okay? So the R that you use is dependent on the unit or the volume and the temperature that we had, okay? So if I could go back to the first question that we had here, the volume had these units, you can see, right? Okay, so if you have those units, okay, then it means your R, you will get this as your R, okay? And then if you have these units as, you have liters as the units for your volume, okay? It means this R is has the value of this, but all these values you are given, so don't worry, okay? It means your R will have a value of 0.0821. Okay, so this is the value of R if the units for the volume are in liters, okay? If they are in cubic meters, we use that 8 point something something, okay? So let's find now, let's substitute what we have here into that equation there, okay? We substitute into that equation. So it means our moles will be equals to, okay, we have 1 atmosphere multiplied by the volume there, which is just 0.0783 over, and then we have our gas constant in this case, which is 0.821 being multiplied by our temperature, which is just 296. Okay, so when we multiply there, what moles are you getting? Okay, so when I divide, what is it showing on my calculator? Okay, so confirm these values, please. Okay, so on my calculator, let me find. Okay, so on my calculator, it's giving me that I'm going to have 3.22 times 10, okay, times 10 to the power minus 3 moles of hydrogen. Okay, remember we're finding the moles of hydrogen here. Okay, then now after finding the moles of hydrogen, we are going to get the mole ratio from the equation. Okay, so from the equation, we had 2 moles of this metal M, okay, that produced 3 moles of hydrogen gas. Okay, so our aim is to find the moles of this, okay, using the moles of hydrogen there. Okay, so we have how many moles of hydrogen gas there? We have 3.22 times 10 to the power minus 3. Okay, so how many moles of this metal M are we going to have? Okay, so we cross multiply there. It means this 3 you multiply by the x, and you have your 3x here. And then on the other side, what will you have? You have a 6.4.4 multiplied by 10 to the power minus 3. Okay, then you divide by 3. Even there, you divide by 3. So what are you going to get there? You're simply going to get, okay, let me do my calculator. Okay, so my calculator has given me a 2.15 multiplied by 10, okay, to the power minus 3 moles of that metal M. Okay, so these are the moles for metal M. So now after getting the moles of metal M, it simply means we'll combine with the mass of metal M. Okay, what was the mass? Let us check. The mass was 0.103. Okay, so this was the mass of metal M, 0.103. Okay, let me write it there. So you have a 0.103 as the mass of this metal M, okay? And these are the moles of metal M. So we are going to combine moles of metal M with the mass to find the molar mass. And once we find the molar mass, it means we know the identity of this metal M. Okay, so we said molar mass is just simply equals to the moles, or not the moles, I mean the mass, okay, over the moles. So mass over the moles, that's our molar mass. Okay, so what is our mass there? It's simply 0.103 grams, okay, divided by the number of moles. The number of moles is this, okay? So I have a 2.15 multiplied by 10 to the power minus 3. Okay, what do I get when I punch this into my calculator? Okay, so let's all punch on our calculators. Okay, so when I divide this, I'm getting a, okay, I'm getting a 47.9 grams per mole, okay, as my molar mass. Okay, so this is my 47.9 grams per mole. I just have to go to my periodic table and check for the element that has this mass. Okay, check for the element that has that mass. Okay, so if I can go on the periodic table here, that was 47. Okay, so 30, 31, 32, okay. 40, 41, 42. Okay, so where is my, okay, you have those. Okay, you can see that my 47 point something is on this element called the titanium. Okay, so it means the identity of that metal is just simply titanium, because titanium is the one that has a molar mass close to the value that we found there. Okay, so it means this metal M is just simply titanium. Okay, that's simply titanium. Okay, so if you have any question on this, you are very free to ask. Okay. Okay, so let's go to number 3 and try to solve number 3. Okay, what is number 3 saying? They're saying the volume of sulfur dioxide can be produced by the complete reaction of 3.28 grams of sulfur, of calcium sulfite with excess hydrochloric acid, okay? So excess hydrochloric acid, it just simply means that this guy there is our limiting reagent, okay? So they're saying what volume of sulfur dioxide can be produced when the final sulfur dioxide pressure is 827 torr, okay, at this temperature, okay? So remember I said whenever you are given a temperature or a pressure that are not in the standard units, you have to convert them back. Okay, so what is this question saying? How can we interpret it? Okay, so they want us to find the volume of this sulfur dioxide that is produced, okay, having done a complete reaction of 3.82 grams of this guy here, okay, in hydrochloric acid, okay? They put this as a solute, which are the mass of 3.82 grams, okay? They place it in a solution of hydrochloric acid, and then a reaction happens. You have water, you have sulfur dioxide, and you have calcium chloride, okay? Now they want us to find this volume here. Okay, so how do you do that? That's what we want to do. Okay, so let's do that. Okay. Okay, so the first thing here that we have to do, okay, the first thing that we have to do there is calculate, okay, the moles of this calcium sulfide, okay. After calculating the moles of this calcium sulfide, we are going to relate it, okay, we are going to get a molar ratio or a mole ratio of this calcium sulfide to the sulfur dioxide, okay. Once we get that mole ratio, it will help us to find the moles of this, okay. And once we find these moles here, we're just going to put those number of moles into the formula for the ideal gas law in order to find the volume of this sulfur dioxide, okay. So the first thing is to find the moles of this, okay. So let's find. So there, okay, my screen has disappeared. Okay. Okay, I hope it's back on your side. I hope you're seeing my board. Okay, so what do we have there? Okay, so we said we have to calculate the moles, okay, of this guy, calcium sulfide, okay. So how do we calculate the moles? We just get the molar mass of this guy, we combine with the mass that was given, and then we find the moles, okay. So moles is equals to the mass over the molar mass, okay. So what mass of this calcium sulfide there was given? Okay, that's supposed to be 3 here, not 4. Because this is sulfide, not sulfate. Okay, so that's the difference. Sulfate has 4, sulfide has 3. So what is the mass of this guy that was given? Okay, the mass was given was 3.82 there. Okay, divided by what is the molar mass of this? Okay, so the molar mass of this, you just go on your periodic table, you get the mass of this plus the mass of this plus the mass of 3 of this. Okay. So if I do that on my calculator, I'm finding that the molar mass there is just 112.14. Okay, so I divide there. What moles am I going to get? Okay, so if I divide there, I'm getting my moles as 0.03406. Okay, moles. So kindly be confirming these values. You can find that my calculator is mistaken. Okay, so after finding the moles of this calcium sulfide, we are going to get a mole ratio of calcium sulfide to the sulfur dioxide. Okay, so you can see from the equation that the mole ratio there of that calcium sulfide to the sulfur dioxide there is just 1:1. You can see, right, from the balanced chemical equation, the ratio is 1:1. Okay, so here you have 1 in front, even there you have 1 in front. Okay, so meaning the ratio there is just 1:1, meaning the moles of this, they're the same moles of that. Okay, so that's what we are going to do here. We're going to say these are the same moles, okay, for the sulfur dioxide, because the mole ratio is 1:1. What am I writing for there? Okay. Okay, so there we have a 2, then is equals to, okay, so we have those moles as the moles of sulfur dioxide. Okay, so after finding the moles, we're now going to the ideal gas formula. Okay, so the ideal gas formula, I said, it states that pressure times volume is equals to moles. Okay, gas constant multiplied by the T there. Okay, now we want to find the volume, meaning we're going to divide both sides by the P. And our volume will just be equals to moles gas constant T, okay, over P. Okay, so this is how we are going to find our volume there. So volume is equals to, what is our N? Okay, our N is this number here that we found, okay, which is our moles. So 0.03406 multiplied by, okay, what is the gas constant? Okay, so this volume, want to find the volume in liters, because there I saw something like milliliters. Okay, so meaning the gas constant there, we are going to use the 0.0821, okay, multiplied by the temperature. What temperature did we have there? Okay, so temperature there, we had 44 degrees Celsius. This 44 degrees Celsius, we have to add plus 273, okay, to get the temperature in kelvins. Okay, so when we add that, we are going to get 7 at the far end there. Okay, 7 plus 4 is just 11. Carry 1. Okay, then 4 plus 2, 6, plus that one, 7. Okay, so we have something like 717 there as our temperature. Oh no, is it 717? No, it's not 717. Okay, so this plus this, 7. Okay, this plus that, it's 11. So 1. Okay, then carry 1. Okay, so it has to be 2. It has to be 2 here. Okay, so this 2 isn't going to be 3.
Yeah, not 3.
Yeah, it's 3. It's supposed to be 3 there. Okay, so you're going to get a 317 there as your temperature in kelvins. Okay, so you're going to put your 317 there Then you divide everything by the pressure. Okay, so what is the pressure? The pressure we are given as 827 torr. Okay, so this 827 torr, we have to convert it to what? We have to convert to atmospheres. Okay, so how do you convert to atmospheres? We know that 1 atmosphere, okay, 1 atmosphere is equals to 762. Okay, so this is the conversion formula. So we have to put these are our 80 at 27 at all. Okay, then we find the pressure in this atmosphere. So when you cross multiply there, okay, what is your X? Okay, so my calculator here is giving me, let me solve. Okay, so my calculator is giving me a 1.0816 atmospheres. Okay, so where there's pressure, we're going to put this amount. Okay, so here we are going to put the 1.088. Okay.
Sir, you said 1 atmosphere is equal to 760 what?
762.
TON.
TORR.
Okay.
Yes. Okay, so now you punch this on your calculator. What volume are you going to get? Okay. So let's punch this on our calculators. Okay, so according to my calculator here, what am I finding? Okay, so according to my calculator, it's giving me a 0.776 liters. Okay. And then this volume, we have to convert it into millimeters. Okay, remember I said what volume in milliliters there of sulfur dioxide. Okay, so whatever volume I found there, I have to convert to milliliters. So how do I convert from liters to milliliters? I just multiply by 1,000, like that. Okay, so meaning my volume there will just be 776 milliliters of this sulfur dioxide. Okay, so that's how you go about that question. So if any question, you're free to ask. Okay. Okay, no question. I'll move to the next one. Go to the next one now. Okay, so we are number 4. And what is our number 4 telling us? Okay, so let's go to number 4. Okay, so on question number 4 there, they're saying what? They're saying zinc reacts with aqueous sulfuric acid to form hydrogen gas. Okay, so you can see here that the zinc has reacted with this acid and they're forming a zinc sulfide there and hydrogen gas. Okay, so in an experiment, 201 milliliters of wet hydrogen gas, okay, is collected over water at 27 degrees Celsius, okay, and the barometric pressure of 733 torr, okay. Then the vapor pressure of water at this 27 degrees Celsius is just 26.74 torr, okay. Then the question is, calculate the pressure of the hydrogen in atmospheres, okay, in this experiment, okay. So calculate the partial pressure, okay, the partial pressure. So here we are calculating the partial pressure. So how do you calculate the partial pressure? Or what is the partial pressure? So the partial pressure is just the pressure that an individual gas will exert, okay, among other gases, okay. So if, for example, I have water vapor, okay, I have water vapor here, okay, which is represented as H2O plus, okay. I also have hydrogen gas there, as these are my two gases, okay. So what is the partial pressure? The partial pressure is just that pressure that this hydrogen gas will exist on its own, okay, without including the vapor there, okay. Or you can say the partial pressure is that pressure that this vapor will exist, okay, without this one, the hydrogen contributing, okay. So how do you find the partial pressure? So the partial pressure, okay, is found from the total pressure. And how do you find the total pressure? The total pressure just simply add the pressure of this water plus the pressure of that, okay, you get the total pressure. And then the partial pressure just simply means you have to, if you're finding the partial pressure of hydrogen, it means you have to subtract From the total pressure, you just subtract the pressure of water, okay, of that vapor. Then you find the partial pressure of this hydrogen gas. Okay, so this is what we are going to do here. I don't know. I hope I'm making sense anyway. Okay, so here we have water and hydrogen. Okay, we have water and hydrogen there. Okay, it was collected over water, meaning we have vapor there. Okay, so the pressure or the vapor pressure here, you can see that we have been given as this value. Okay, and then the barometric pressure. Okay, so the barometric is the total pressure. Okay, so total pressure have been given, and then the vapor pressure of water will be given. Okay, so we just have to calculate now the partial pressure of hydrogen. Okay, so what formula are you going to use there? You're going to simply use this beautiful formula. Okay, very simple and straightforward. Okay, you're going to say, okay, let me write it in general terms in case they bring for you another question, but a similar concept. Okay, so you're going to say partial pressure. My PP will represent partial pressure, okay, of any gas. Partial pressure of any gas, okay, is equals to the total pressure, okay. The total pressure is also known as the barometric pressure, okay, minus, okay, the pressure, minus the partial pressure of another gas, okay, of another gas there. Okay, so in these terms, we're finding the partial pressure of hydrogen, okay, meaning we're going to subtract the total pressure minus, okay, the partial pressure of our water, okay, water vapor. Okay, so that's the formula. So it's equals to, what was the total pressure there? The total pressure 733, okay, minus, what was the total, the partial pressure of this water? Okay, let me check, forgot it. Okay, so you can see that the total, the vapor pressure of that water was just 26.74, okay. So 26 there, 0.74. This is a very simple question, right? Okay, so you subtract that, and what are you going to get? Okay, you're going to get 706.262. Okay, so remember they said our answer should be in atmospheres. Okay, our answer should be in atmospheres. So remember the conversion factor, 1 atmosphere is equals to how many to 762. Okay, so that's what we have. And then here we have our 706.26. Okay, so X, we're finding our X. So X will just simply be equals to this 706.26, okay, divided by 760 there. Okay, so we have a 760 there. Okay, so when you divide this, what are you getting? So consult your calculators. Let me also do my calculator here. Okay. Okay, so what I'm getting there is just simply, what am I getting? Okay, let me divide again. So I have a 706.26 divided by a 760. Okay, so I'm getting this as my answer. 0.7273. Okay, so I'm getting this as my partial pressure for the hydrogen. Okay, remember we're finding for the hydrogen. Okay, so I don't know if anyone has a question there before we move to the next one. Okay.
Yes, I have a question, sir.
Yes, you can ask.
So is it necessary to show the whole figure, or is
Which
not
figure?
that necessary?
Which
Like
figure?
after you divide 706.26 by 760, like the whole figures, like since I don't know you have
On the
rounded,
calculator.
off. Yes.
Okay,
Is
yeah.
it important to show them?
Okay, it depends on your lecturer or the one who's marking. Okay, so but to be safe, you can show it here. You can show the whole figure here first. Okay, then you round it off at the end.
Okay, so like
that's
according to the question, how many are you supposed to round off since the figures that you've been given?
okay. So the general one is rounding off to 3 significant figures. Okay, did they mention in the question? Okay, they didn't. So
No,
if they
they
don't
didn't mention.
mention, just leave your answer to 3 significant figures. Okay, even 4 is
Okay, thank you
okay.
very much.
So 3 or 4. So you can either represent it as
Okay.
this or the way we've done here. It'll be okay.
Okay, thank you very much.
All right. Okay. Okay, so let me look at the other question there before we move to the other tutorial, because this concept, they are just the same. Like the whole question 5 there, the concept are just the same, even the question 6. Okay, so let's solve some from question 5. Okay, so here they're saying a certain sample of dry air of total mass, this consists of entirely 0.76 grams of nitrogen and 0.24 grams of oxygen. Okay, calculate the partial pressures of these gases when the total pressure is that. Okay, so there, what are you going to do? Okay, so anyone who has an idea there, how do you find the partial pressures there? Anyone? Before I come in, how do you think we are going to calculate the partial pressures there? Hello? No one has an
I
idea, guys.
think you, so I think you calculate the pressure of oxygen first, for example, then you subtract it from the total pressure, then you find your answer, and then you do the same for nitrogen.
Okay. All right. We can use that approach. Okay. My phone is saying Robert. Let me make one. Okay. Okay. Okay, I've made bundles. Let's continue. Okay, so someone said we have to first find the pressure of the oxygen, then we subtract. Okay, so we can go with that concept. Okay, or we can also go with another one. Okay, so let's use the one that she said. Okay. Let's use the one that she said. Okay. Okay, so let's as first find the moles of using this mass of nitrogen, we can find its moles. Okay, and even here using the mass of oxygen, we can still find the moles there of that oxygen. Okay, so how do we do that? Okay, how do we do that? Okay, so we're given 0.6, 0.24 there. Okay, so we are first going to find the moles of oxygen, and then we find the moles of nitrogen. Okay, so moles of this oxygen, how are we going to find? Okay, so we are given the mass there. So with the moles, we know that we divide the mass, okay, over the molar mass. So the mass of oxygen that we have there, we just simply 0.24. Okay, then we divide by the molar mass of oxygen. We know the molar mass of oxygen. That's it. Okay, so how many moles do you get there? Okay, so there you will get 0.00750. Okay, as your moles of oxygen. Then what are the moles for this nitrogen gas? Okay, so mass of nitrogen, which is 0.76, divided by the molar mass of nitrogen. Okay, what is the molar mass of nitrogen gas? It's just 28. Okay, so there, what are you going to get? I'm going to get a 0.0271 moles according to my calculator. Okay, so after that now, okay, after that, you can use a formula for you to determine the partial pressure of each gas. Okay, so we can determine the partial pressure of one gas. Okay, then to find the partial pressure of the other gas, we use that formula that I said the total pressure is equals to the sum of two partial pressures. Okay, so let's do that. Okay, so here we are going to find the the moles of this nitrogen. Okay, we're going to find the moles we've already found here. So we are going to find the pressure of this nitrogen. Okay, if you want, you can start with the pressure for this oxygen. Okay, so what formula are you going to use there? So remember the ideal gas formula. Okay, remember the ideal gas formula there. So what does the ideal gas formula state? Okay. Okay, so do we use the ideal gas formula here? No, we use this formula. Okay, because they were not being given the conditions, like it's at which temperature, so we can't use that formula because we won't have a temperature. Okay, so you say the partial pressure of this nitrogen, okay, is equals to, okay, is equals to okay, is equals to X, which is the number of moles there, times the total pressure. Okay, here's the total pressure there. Okay, times the pressure for the oxygen. Okay, as the pressure of the oxygen. Okay, so how are we going to navigate through that formula? Okay, how are we going to navigate through that formula? Okay, so there we are saying that the partial pressure of nitrogen, okay, the partial pressure of nitrogen should be equals to the moles, okay, the moles of nitrogen divided by, okay, I'm supposed to write divided by here, divided by the moles of nitrogen plus the moles of oxygen. Okay, so I don't know what I was writing there. Okay, so the partial pressure of this nitrogen there, okay, should be equals to the moles of this nitrogen gas. Then you divide these moles of this nitrogen gas, okay, by the moles of oxygen plus the moles of the same nitrogen gas, like that. Okay, so we are going to use that formula there. Okay, meaning on top there, what are we going to have? What were the moles that we found for this nitrogen? So the moles for the nitrogen, we found that it was 0.0271. Okay, then down there, we're going to put the moles of oxygen and the moles of nitrogen. Okay, so moles of oxygen, we had 0.00750 there. Okay, I don't know if this is the correct number. Okay, this is the correct one. Then you say plus the moles of nitrogen, okay, which is the same here. Which means the partial pressure there of this nitrogen is equals to whatever we get after dividing this. So if I divide, what am I getting? Okay, if I divide, what am I getting? Okay. Okay, so if I divide, I'm getting my partial pressure. As if, okay, if I divide this, I'm getting 0, okay, I'm getting 0.8, oh, no, not 8. Okay, let me do this calculation again. Okay, so there I'm dividing what? I'm dividing a 0.0271 in brackets, then divided by, okay, what do I have down there? I have 0.00750 plus 0.0271, okay? So I have a 0. This is correct now. I have a 0.7832, okay? So this is my mole fraction of this nitrogen gas, okay? Because there I was using moles. So my mole fraction of the nitrogen gas is this, okay? So then to find the partial pressure now, I have to multiply, okay? That mole fraction that I have, I multiply it with the total pressure there. Okay, so what was the total pressure that was given in the question? The total pressure was 0.87 there. Okay, so I'm going to multiply this by a 0.87 there. Okay, so 0.87 there is equals to, I'm finding a 0.68, okay, as my partial pressure. Okay, I'm finding this as my partial pressure of this nitrogen gas. Okay, So this is the partial pressure of nitrogen gas. Okay, so I should have written that this formula in the correct way. I don't know why I didn't, but let me show it here for the sake of simplicity. Okay, so the partial pressure of this nitrogen was equals to the moles of nitrogen on top, okay, moles of nitrogen divided by moles of oxygen, okay, plus moles of nitrogen again, then multiplied by the total pressure that we are given. Okay, so this is the formula for finding the partial pressure of this nitrogen. Okay, so if you want to find for oxygen, you put your oxygen there, nitrogen there, oxygen there, still multiply by that. Okay, but if you don't want, okay, you say the partial pressure is equals to, the total pressure is equals to partial pressure of nitrogen, okay, plus partial pressure of oxygen. Okay, so we have the partial pressure of nitrogen, which means we can find the partial pressure of oxygen there. So partial pressure of oxygen here will simply be what? The total pressure minus the partial pressure of nitrogen. So what is the total pressure there? It's just 0.87. Then minus, what is the partial pressure of this nitrogen? Partial pressure of this nitrogen, we find 0.68, okay? Where is the, 68. So we subtract there, and what are we going to find as our partial pressure of oxygen? So 0.87 minus 0.86, okay? I'm finding my 0.19 there, atmospheres, as my partial pressure for the oxygen. Okay, so once you have one, it's simple to get the other one. I don't know if anyone has a question on these partial pressures.
So there are two methods of calculating partial pressure, right?
Yes.
Okay, when do you know which one to use?
You can use anyone. You can use any of the two.
Okay.
Yes, you can use any of the two. So when you're using this, okay, this one here, the one I wrote here, make sure that you have the moles for both gases that are present, okay? So here we have the moles of oxygen, also have the moles of nitrogen. And make sure you have the total pressure there is given. Then you can use this one. Okay, then after finding for one, you can find for the other one by simply using that formula there. Total pressure is equals to the partial pressures of the gases that are present there. Okay, so that's how you do that. What else here? Okay. So this one, okay. So I think we solved enough for the pressures. Let's solve some for the atomic structure now. Okay. So I want you to solve these questions here. Okay, you can send your solutions. I can guide you. Okay, if you won't find the correct answer. Okay, but simply apply the same concept that we are using to solve all these questions that we've solved there. Okay.
So in this video, I'm going to show you how you can register for our lessons. Okay, so what you need to do is open your browser. It can be Google Chrome, Samsung browser, or any other browser that you are using. And then you type in DISCRETE learning, okay, DISCRETElearning.com. Right, so once you type in, you click enter or search, and then it will load and it will take you to this login page. So if you have an account, just go straight in and log in, okay? If you do not, you need to create an account. So I'll click create an account, okay? So create an account, and then this here will pop up. So you put your names there. So I am Poul, solutions, and then here you put in your email, okay? And then here you put the password that you want. So I'll put 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can put any password that you want there. Here you're going to type your phone number. Okay, and then here you put your date of birth. So I was born on 6th February 2025. Okay, so you can put any date of birth there. And then here you are going to select your university. Okay, so we have a lot of university here. You can see there's Gonza, CBU, Mulungushi, Cavendish, all these universities. Okay, so you click the university that you belong to. Okay, so for example, I'm going to click University of Lusaka. Okay, and then you click register. Okay, so it's going to load and it's going to tell you that you have successfully created your account. So what you need to do now is put in the details that you registered with. So you put in your email here that you used, and then there you're going to put in the password that you set, and then you click login. All right, so once you log in here, it will take you to this dashboard. Okay, so this dashboard here, okay, let's remove this. So this dashboard here has all the courses that we offer. So there's chemistry, math, physics, biology. Okay, if you're taking linear algebra, you can register, introduction to real analysis, all that. Okay, so let's say, for example, you want to register for mathematics. So what are you going to do? Okay, you're going to click open. Okay, so you can see they're saying you're not enrolled in this course. So what you need to do is click subscribe. Okay, and then it will bring all the courses that we offer. So you tick the one that you want. So maybe I want to register for mathematics, okay, and chemistry. And then on the right here, you choose the duration. Okay, so I'm going to say math 1 month, even the chemistry 1 month. Okay, let me even put physics and biology here. So I'm registering for those 4 courses. So once you click, once you select the courses, you're going to click enroll. Okay, you wait for it to load. It will take you to this page that will show you the total amount that you're going to pay, okay, for all those courses that you've selected. Okay, and then you click pay. All right, so you're going to have this drop down that is going to come. Okay, so here you put the phone number that you're going to use to pay. Okay, you put the phone number that you're going to use to pay. If you're paying using maybe a mobile money agent, okay, tell them to put their number here. Okay, and then you click pay now. Okay, so it's going to load. So you wait for it, and then it's going to take you to this page. Okay, so here it's telling you about to pay DISCRETE Learning Institute the sum of whatever they are. Okay, so what are you going to do here? You are going to click pay. So once you click that pay, okay, this page here is going to pop up. Okay, so once this page pops up on your phone or your PC, okay, you are going to receive a pop-up message on your phone telling you to import the password for your mobile money. Okay, so once you import the password for your mobile money, you will be able to be letting into the website. Okay, it means you have registered. Okay, so let's say, for example, let me put in my password on my phone now. Okay. Okay, so when you come back to the dashboard, you are going to see that now you are enrolled in math, chemistry, physics, and biology there. Okay, so allow me to explain some of the things that you can see here. So on this menu here, if you click that menu, the menu will disappear. If you click it again, it will appear. So on the menu there, we have this where it's written learn. Okay, so when you click on learn, you're going to find all the courses that you are registered in. Okay, and then you can close that. You can click YouTube channels. You're going to find our YouTube channels there. Okay, so you can click maybe Tutor Poul Solutions. Okay, you're going to go to my channel here, and then you can watch some of the videos. Okay, to ask you to subscribe, so you subscribe. So it will show you some of the videos that I've uploaded on my YouTube channel. Okay, but on the website we have a lot of them. So I'm going to show you how you can access all that. So let's go back here. All right, so on my YouTube channel, you mostly find math and chemistry, and then for Tutor John, okay, for Tutor John, you're going to find biology and physics, and then for math with Marius, of course, you're just going to find math. Okay, so I can close that, and then I open this one for study materials. So when I click on study materials there, it's going to take me to this page where we have different study materials based on your university. So if you're from Apex, you open the Apex folder. If you're from Unilas, you open the Unilas folder. Eden, you open that just like that. If you're from UNZA, you open the one for what? For UNZA. All right, so let's go back there and then check what we have inside the courses there. So we have talked about all these here, okay, on the menu. So if, for example, you want to learn something, okay, you just open, okay, this course, and then you're going to, if you open math, you're going to find general mathematics and probability and statistics for second semester Apex. So this one here is specifically for those who are doing second semester Apex. Okay, for the rest of you, you just go in the general mathematics. Okay, so you're going to find 4 folders there. One will be for the lessons and tutorials. The other one will be for the handwritten notes. The other one will be for the tutorial sheet and assignments. The other one will be for what? Past quiz, tests, and exam papers. Okay, so the setup is the same. Even if you go in the chemistry folder, the biology folder, the physics folder, any folder that you go into, you're going to find the same. So if you go in lessons and tutorials here, okay, you're going to find all the topics that you can have in math. So you can see there are a lot of topics, right? So let's say, for example, I want to learn maybe SADs and rationalization. So I'll click SADs and rationalization there, and then I'm going to find 3 folders. Okay, so the first one is for the notes. The second one is for the recorded tutorials that we record for ourselves. And then here where I put supplementary tutorials, okay, there are other videos that you can use to learn. So if I click on slides and notes here, you see you are going to find the notes here. So you can click any to study them. Okay, let's click this one here. All right, so the notes are going to open like that. Okay, so they have opened there, so you can go there and you can study them. Okay, so these are your notes to study, so make sure you study them. They are very simple and simplified. Okay, so what if I leave these notes? Okay, I also have these notes here that I wrote by myself. So we can go through these notes to learn. Okay, so if you don't want to read the notes, you want the videos, you go in the recorded tutorials. Okay, so you click there, you're going to find the videos here. So there's intro to SADS, whatever I can see there. Okay, so let's play the introduction to SADS. So you click on it, it's going to open like that. If you're using a PC, so you can move a bit up like that, and then you play it. Okay, so you can start learning here. Okay, you can start learning. You can see the video is playing. If you want to fast forward, you just click on these two things here that are on the screen. So you can double click on them. You'll be fast forwarding your video. And then at the end here, okay, at the end here, I have these two icons here. Okay, so the last one there puts you in full screen mode. So if I click it like that, my video is going to appear in full screen mode like that. Okay, so you can watch your video in full screen mode like that. Okay, if you don't want the screen mode, the full screen mode, you can still watch. That's the way it is there. Okay, so we also have this icon here. So this icon is for picture in picture play. Okay, so you can play your video while doing something else on your PC. So if you click on it, you see I'm going to have this that small thing popping up there. So even this is on your phone. So you can be playing your video there, and then you can even leave this browser. Okay, so you can even go somewhere else. Okay, like this. So you see it's still there. Okay, so you can play it. And then to return to full screen mode, you just click on it, and then you'll be able to return to the full screen mode here. All right, so that's it on the lessons and tutorials. The setup is the same in all these topics that you can see. So just pick the topic that you want to learn, and then you'll be able to learn. All right, so after that, you can check out the handwritten notes. Okay, so these handwritten notes, most of them have a password. Okay, so the password is PB4511. Okay, so you can open the ones for set, you'll find them. Okay, you study them just like that. So these are very good notes. They are very simplified. So make sure you use them. All right, so those are the handwritten notes. And then when I go to the tutorial sheet and assignments here, I'm going to find different universities. Okay, so if you're from Apex, you go in the Apex, you open, you're going to find video and written solutions. So the video solutions, you open there, you're going to find, depending on your intake. So this was for the January 2024 intake. This was for the 2024 July. And then for your intake, which is 25 this year, you place there. Okay, so you see the videos that we've solved so far there. Okay, so you can open them if you want to learn. So it will come, you can play it, and you'll be able to learn there. Okay, and then what else? Okay, you can also check out the written solutions here. You're going to find some of the written solutions that we upload there. All right, so if you do not see your university here, you can go in this folder where we wrote our tutorial sheet and explained solutions. Okay, so you open this folder, you're going to find a lot of tutorial sheet based on all the math topics, okay, that you can have. So this tutorial sheet here have solutions. So for example, if you want to learn functions, okay, if you want to learn functions, you just have to open this folder here. Okay, just have to open this folder. Okay, let me say I want to open the one for the logs and the exponentials. So you click on it. So it's going to open here. Okay, so you have the questions here. Okay, so you can take note of the questions that you have and then try to solve them. And then once you are done, go below the questions there. You're going to find the solutions. So these are the solutions there. Okay, these are the solutions there. So you can learn using them. Okay, so you can go back there. And then if you are taking a stats and probability, we have some tutorial sheet here. So you can open and then you can check them out. Okay, we also have more worksheets on the probability and statistics. You can check them out there. All right, so we are done with the tutorial sheet folder. Okay, so you just go to your university there. And then when you go to the past quiz, test, and exam papers, you're going to find a similar setup, okay, to the tutorial sheet folder. So if you're from Apex, you go to Apex. If you're from Unilas, you go to Unilas. If you're from Mukuba, you go to Mukuba. So for example, if I go to Mukuba here, I'm going to find video solutions, okay? You can see the video solutions for some revision of their test papers. And then even you can even go in the written solutions there. You're also going to find the written solutions. Okay, and then here we have some past papers on probability and statistics. All right, so that's how you can use this drive. Okay, so feel free to try out whatever you want. Okay, so search for whatever you want on this drive. You're going to find them. Okay, even in the chemistry there, if you open, it will be a similar setup, general chemistry for the rest of you. Okay, and then if you're doing second semester Apex, you go in this folder here. Okay, so let's try to go in the general chemistry there. You're going to see the setup is the same. Okay, so if I go tutorial sheet maybe, and then I open the folder for UNZA, okay, you're going to see video and written. Let's try to open the written ones. You're going to see the tutorial sheet for the chemistry that they take at UNZA. So you can open any. Okay, you can open that. You find all these tutorial sheets that are solved. Okay, you can open this folder, you find all these tutorial sheets that are solved. So make sure you use what is on the drive. Okay, so our Learning Institute, okay, is the best because you can learn at any time, anywhere. Okay, you don't wait for us to teach you. You can actually teach yourself. Okay, but we also have live classes. So when you register, you have two types of classes that you're going to be attending. Okay, one is the live classes where we interact and you can ask questions. And then the other one are the recorded classes that you find on this website. All right, so that's all about this website. Feel free to register yourself and then start learning, okay? Thank you so much.